Right, the 2014 School Graphs Exam, question 2. You can have a read. So first thing we'll do, have a look at what it's going up in steps of. Follow the same pattern. Total will be after 8 weeks. Well, we should finish off the table. We can see that they should have $69. Okay, part 2, so I don't lose the table, says write an equation to model this. So you can go into stat, put the points in. Now, clearly it's not linear because it's not going up in the same step size. However, if I look at the second difference, it is the same each time. So that tells me that this is a quadratic pattern. It has something to do with this number squared. So I should choose x squared when I get to the screen that asks me. And coming up with an answer, it comes up y equals ax squared plus bx plus c. It says that a should be 1, b is 0, and c is 5. So we need to be really careful how we put that into our rule. A is 1, b is 0, so that term is gone, and c is 5. Now it doesn't have any variables here. If you read part 2, it says write an equation to model this pattern for n weeks. So they clearly want us to use n for weeks. It's up to you. Oh, and then they have a t for the total. T equals. So it would be t equals 1n squared plus 5. So there's your answer to the rule. And you could check it, actually. 3 squared is 9. Plus 5 does give me 14. 2 squared is 4. Plus 5 gives me 9. Try one more. 4 squared is 16. Plus 5 gives me 21. So I'm quite happy that that rule is working and doing what it's supposed to. Now the next one asks me to draw a graph. The total amount that will be raised up to 8 weeks, so we might just need to reduce that a little bit. So plotting it, after week 1 the amount donated was $6, so there's 10, so 6 will be about there. After 2 we had 9, now it's not going to stay on this graph. After 3 we had 14. After 4 was 21. Keep going up to 30. 6 was 41. Oh, see, I'm losing it. Next one was 54. It's 50, 54. Oops, 54 will be there. Not that one. And week 8, of course, we were at $69, which is just about 70. So it's going up in a gradual curve like that. You can actually look, make sure that yours is a bit better than that. I'm probably going to end up losing that. Right, this time we have an equation. Capital T. So that'll be T, and that'll be N for weeks. So this is James. Right, let's try with 3. So that'll be 2 to the power of 3 minus 2. 2 to the power of 3 is 8, minus 2 is 6. 2 to the power of 4 minus 2. 2 to the 4 is 16, minus 2 is 14. And you can check these numbers. I think we should go up to at least 8, like the previous graph. Part 2 says use the graph or otherwise to find after how many weeks will James and Gemma have the same amount of total donations. Now there was an and up here, and it did say to draw this model on the same graph, so we'll see how we go. Obviously you want to use different colours or some way of telling them apart. So if I use, let's use blue. So this will be for James. James 1 was 0. Once again these might not stay. 2 was 2. 3 was 6. Now that's 10, so 6 is only about there. 4 was 14. 5 was 30, so there we go, that's where they're both the same. After that 6 was 62. And then we had 126. And 254, which you can try and put on there if you like. Now the red was Jenna, so we need some sort of key. Part 3 again, here we go with the comparing the graphs of the total donations and comment particularly on the rate of growth. Now the interesting thing about this is that the red one, Jenna's one, was a quadratic. Remember the rule, we found it, n squared plus 5. Whereas James's one in the blue comes from 2 to the n minus 2, which is actually exponential because the power is the unknown. That's an exponential rule. So that's one major difference. Similar that they're discrete payments, not continuous, we're not joining them up. The payments we're paying week 1, week 2, week 3, week 4, the amount donated, sorry. But a major difference is that James's one is exponential, which has exponential growth, which of course is much steeper, much quicker, gets much steeper, much quicker than the quadratic graph. They're both the same at 5 weeks for $30. We could talk about the y-intercept. Once again, it doesn't really make sense in this situation, but you could work it out. For Jenna, her y-intercept, remembering that her rule is n squared plus 5, so if we substitute 0 in there, we'll get a y-intercept of 5. And for blue, for James, his was 2 to the n minus 2, so on a calculator you can check 2 to the 0 is 1, minus 2 is negative 1, so they will have different y-intercepts as well. Right, so let's see what we could have written. That one we answered. Now just do your best here. Both graphs are discrete. Using whole weeks. James' graph is exponential. Jenna's is quadratic. Both graphs are the same at week 5 for $30. Y-intercept, if we want to, not really relevant for this situation. However, for James, we worked it out. 2 to the 0 minus 2 equals negative 1. And for Jenna, it was 0 squared plus 5, which is 5, so they're different. And then of course it's really important that we do comment on the rate of growth. James's growth rate appears slower initially, but because his is exponential, rate of growth increases much quicker. And of course that gives a steeper graph. Than Gina's.